Welcome to G Fun Facts Online. For centuries, we've looked at the stars and asked one of the most profound questions imaginable. Are we alone? And in our own cosmic backyard, no world has captured our imagination quite like Mars. Today we're diving deep into the astrobiology of the Red Planet, a story of tantalizing clues, robotic explorers, and a discovery that might just change everything. Our fascination with Martian life isn't new. It began in the 19th century with astronomers like Giovanni Schiaparelli, who sketched what he called canali, or channels, across the Martian surface. Percival Lowell famously expanded on this, imagining a dying Martian civilization building intricate canals to ferry water from the poles. We now know these were just optical illusions, but the idea of a living Mars was planted firmly in our collective mind. The space age turned this dream into a scientific mission. After early flybys showed a cratered, seemingly dead world, the Viking missions of 1976 represented our first real attempt to find life. Two landers touched down and ran experiments specifically designed to detect biological activity. The results were baffling. Some tests came back positive, hinting at microbial metabolism. But others found no trace of organic molecules, the very building blocks of life. This contradiction sparked a debate that lasted for decades. The scientific consensus eventually landed on a non-biological chemical reaction as the cause, but Viking taught us a crucial lesson. Finding life on another planet is incredibly difficult. Since then, our strategy has evolved. Today, the mantra of Mars exploration is simple: follow the water. Life, as we understand it, needs liquid water to exist. And mission after mission has confirmed that ancient Mars was a very different place. Orbiters have mapped vast, dried-up river valleys, deltas where water once flowed into massive lakes, and shorelines of ancient oceans. Rovers have driven across these exact landscapes, acting as robotic geologists. The Mars Reconnaissance Orbiter gave us breathtaking high-resolution images, revealing a planet sculpted by water. Then came the twin rovers, Spirit and Opportunity, in 2004. They were our boots on the ground, and they found definitive proof in the rocks that liquid water once flowed freely on the surface. They set the stage for what was to come. But here's the catch. Modern Mars is a frozen desert. Its atmosphere is incredibly thin, less than 1% the density of Earth's, and it's mostly carbon dioxide. This offers almost no protection from the sun's harsh radiation and cosmic rays that bombard the surface. Temperatures swing wildly, from a pleasant 20 degrees Celsius during the day to a bone-chilling -73 at night. The atmospheric pressure is so low that any liquid water on the surface would instantly boil away. To make matters worse, the soil is laced with toxic chemicals called perchlorates. So, if life does exist on Mars today, it's almost certainly not on the surface. Astrobiologists believe the best place to look is underground. Shielded from radiation, subsurface environments could potentially trap liquid water, possibly kept warm by geothermal heat from the planet's core. This is where our most advanced explorers come in. In 2012, NASA landed a 1-ton, car-sized mobile science laboratory named Curiosity in Gale Crater. The crater was chosen because it has a massive mountain in the center, Mount Sharp, whose layers of rock act like a history book of Mars. Curiosity's mission wasn't to find life itself, but to answer a critical question: was Mars ever habitable? The answer was a resounding yes. Curiosity discovered that billions of years ago, Gale Crater held a freshwater lake with all the chemical ingredients necessary to support microbial life. It found complex organic molecules, the carbon-based building blocks of life, preserved in ancient mudstones. Then, in 2018, it detected something truly tantalizing: seasonal variations of methane in the atmosphere. Methane is a fascinating gas because while it can be produced by geological processes, on Earth, a huge amount of it is produced by living organisms. The methane levels on Mars rise in the summer and fall in the winter. We still don't know the source, but it remains a compelling mystery. More recently, in early 2025, Curiosity found large deposits of iron-rich carbonates, which form when carbon dioxide, water, and rock interact, further cementing the evidence that Mars once had a stable, habitable environment. Building on Curiosity's success, the Perseverance rover landed in February 2021. Its mission is even more ambitious: to actively search for signs of past microbial life, what scientists call biosignatures. Its landing site, Jezero Crater, was once a deep lake fed by a winding river, which formed a fan-shaped delta. On Earth, river deltas are fantastic at trapping and preserving organic material and signs of life. Perseverance is our most sophisticated geologist yet. It's equipped with instruments that can analyze rocks with incredible precision. But its most important job is to drill core samples from the most promising rocks, seal them in ultra-clean titanium tubes, and leave them on the surface to be collected by a future mission and returned to Earth. And in September of 2025, while exploring a region on the crater's western edge, Perseverance analyzed a rock nicknamed Chayava Falls. The sample it drilled from this rock, now known as Sapphire Canyon, may be the single most important sample ever collected on another world. NASA's announcement sent waves of excitement through the scientific community. The analysis revealed a combination of materials that is extremely suggestive of biology. Inside the rock, Perseverance found organic carbon. That's significant, but we found organics before. The key was what it was found with: minerals called vivianite, an iron phosphate, and greigite, an iron sulfide. On Earth, this specific cocktail of reduced iron phosphates and sulfides, found right alongside organic matter, is often a direct result of microbes consuming that organic matter. It's a hallmark of a biological metabolism. Michael Tice, a geobiologist on the science team, explained the significance. While it's technically possible for these chemical reactions to happen through purely geological means, they typically require very high temperatures. But there is absolutely no evidence of high heat in the surrounding rock. Everything points to these reactions happening in a low-temperature, watery environment, exactly the kind of environment where microbes would thrive. Nikki Fox, the head of science at NASA, put it this way: "Today, we are really showing you how we are kind of one step closer to answering humanity's most profound questions, and that is, are we truly alone in the universe?" The science team is being very careful. They are not claiming definitive proof of life. As acting NASA Administrator Sean Duffy noted, they simply, quote, "can't find another explanation for what they're seeing." But it is, without a doubt, the clearest sign of potential ancient life ever found on Mars. The Sapphire Canyon sample is now sealed and waiting for the day we can bring it home. So when scientists talk about looking for biosignatures, what do they mean? It's not about little green men. A biosignature is any substance, object, or pattern that requires a biological agent for its origin. We can group them into a few categories. First are chemical biosignatures, like the complex organic molecules and lipids found by Curiosity and Perseverance. Second, we have mineralogical biosignatures, where microbes create or alter minerals. The iron phosphates and sulfides in the Sapphire Canyon sample are a perfect potential example of this. Third are fossil biosignatures, the preserved physical remains of organisms. These could be microscopic fossils of bacteria or larger structures called stromatolites, which are layered mounds created by entire microbial communities. And finally, there are atmospheric biosignatures, like the mysterious methane gas that Curiosity detected. The challenge is that many of these signatures can also be created by non-biological processes. That's why the burden of proof is so high, and why getting these samples back to Earth is so critical. This leads us to the future. The next great chapter in Mars exploration is the Mars Sample Return Mission, or MSR. This incredibly complex, multi-stage mission, a partnership between NASA and the European Space Agency, is designed to launch a lander to Mars. Use a small rover to pick up the sample tubes left by Perseverance, launch them back into Mars orbit, where another spacecraft will capture them and fly them all the way back to Earth. Once here, we can analyze them with the full power of our planet's best laboratories, using equipment far too large and complex to ever send to Mars. However, MSR is facing major budget and schedule challenges, and its future is currently being reevaluated. But the goal remains. Beyond MSR, other missions are planned. The European ExoMars rover, named Rosalind Franklin, is designed with a drill that can reach 2 meters below the surface, far below the reach of radiation, to search for life where it may still be protected. And in the long term, the ultimate goal is to send humans. Astronauts on Mars would be a game changer. They could conduct fieldwork 1,000 times faster than a rover, make real-time decisions, and explore complex terrains that are off-limits to our robotic explorers. The search for life on Mars is more than just a scientific project. It's a story about human curiosity and our relentless drive to understand our place in the universe. From the imaginary canals of the 19th century to the ambiguous results of Viking, from following the water to the stunning discoveries of our modern rovers, every step has brought us closer. The Sapphire Canyon sample represents a potential turning point in this epic quest. Whether Mars is now a fossil planet, holding only the ghosts of a long-lost biology, or if life somehow clings on in a hidden refuge deep underground, we will keep looking. The red planet is holding its secrets close, but for the first time, we may have found the key. The story is far from over. Thanks for listening to G Fun Facts Online.